Hi, this lesson today is mainly talking about translations, and then at the end we're going to talk about transformations. I'm holding this up in case you want to copy down this outline. We've done translations and transformations so many times that this lesson should actually go by pretty quickly once you write that down. I know it seems like a lot, but we've done this, like I said, so many times, so we should be able to just go right through this. Okay, so the first equation, let's see how I'm going to get this to work. Can I make this smaller? There we go. Okay, so the first equation is right here, and we notice that I put the equation and then I put the parent function. So we should be able to remember that this is quadratic because the largest exponent is 2, and so that's the parent function. So what translation has taken place? It's going up 9. And then if I drew a little sketch of it, this is the parent function here, and then this would be g of x moving up 9 spots. Okay, so just kind of a little sketch of what's happening. That's the parent function. All right, so we're gonna kind of go through these pretty quickly. This is going down 2. Once again, still quadratic, same parent function. I'm just sliding it down 2, so that's my g of x right there. Over here, since it's in parentheses, you're shaking it up. It's the opposite to what you think. So it is going right to, my little sketch would be going right to, and that's my g of x. Over here, it's in parentheses, so it's the opposite. It's going left 5, whoops, left 5. Once again, I can draw my sketch, go left 5, and that is g of x. Okay, so those were just translations, and translations are types of transformations for quadratic. And if you move down here, then you should already know in your head that these are now absolute value functions. And absolute value functions look like V's or upside down V's, but since these are just translations, though they're just slides, we aren't going to be flipping them. So here, once again, is the function that I want to translate, and here's the parent function. So we know that it is going up 2. If I did a little sketch, that is my parent. That's supposed to look like a V. That is my parent function, and I'm moving it up 2, so that is now h of x. Over here, down 5. Right here, I'm shifting it down 5, and that is h of x. Over here, because it is in my absolute value side, and that's similar to parentheses, it's opposite to what I think. It's going left 1. And that is my h of x right there. This one, I am going right 5. That's my h of x. So this is, like I said, you're probably going, yes, 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 Miss Knight. We've done this again and again and again. Now, so here is my square root functions. The same gist of it. So here's the parent. Here's the function that I'm going to translate, and here's my parent function. We remember that a sketch of my parent function just basically looks like that. Well, what's happening, this plus 5 is not under the radical, so I go up 5. So I'm basically just shifting this up 5, and that's going to be my I of x. Over here, because that is underneath the radical, it's like shaking it up opposite to what I think. I'm going right 3. And if that is my parent function, I'm just moving it, right 3, which is over here. Okay, and on the bottom, it's a cubic function. So we kind of have to remember what a cubic function looks like. If you remember, it's like this. All right, and then what is this asking it to do? It's asking it to go up 4. So I'd be shifting it up 4. So that would be j of x. And here, this one, since it's underneath, it's going to go right 2. So you can see that basically we've done a ton of those before. So what I want to do is just show you, a few more. And so these, I wanted to touch base with you about some transformations. So translations are when you just slide it, and transformations are when you do things like flip, make it a vertical stretch, vertical shrink, skinny or narrow, or that stuff. So go ahead and write this, and this will be the end of our notes today. So here you are going to, here is the equation that we're doing. So remember, if we have a negative in front, it's just telling us to reflect it. So this is the parent function. So we're going to reflect it. If I did a sketch, that's an absolute value sign, so it goes like that. Well, if I have to reflect it, I'm gonna flip it over. So that is my j of x right there on the bottom, this part right here. The next one is a quadratic. So once again, I'm going to reflect it because that negative in front of the entire thing, in front of the x squared or the absolute value sign or the radical. So these are all going to be reflect, right? Here, this is the basic quadratic. When I reflected it, now looks like that. So that's my j of x. Here, the basic the square root function looks like that, and I'm going to end up flipping it, so it's going to look more like that. Okay, now so let's talk about vertical stretches and vertical shrinks. If you notice here on all of these numbers are larger than 1, and then down here these numbers are smaller than 1. So that's the big difference here. Okay, because it's larger than 1, it's going to be a vertical stretch. And that's what's going to happen for all of these. So I'm just going to put those marks. Remember, those marks mean copy whatever's on top of it. So all of those 3 are a vertical stretch. When I move that over, I have an absolute value that looks like this as a parent function. And when I vertical stretch it, it gets skinnier. So now this is what my k of x is. Okay, the skinnier one there. And then the same thing's happening here. Let's just do, okay, if I have this, right, and I am going to make it, I'm bringing it closer up like this. So this is now where it's going to go to. It's going to stretch like that, getting closer to the y-axis. So that is going to be my k of x. And then here, this is what the parent function looks like that. Square root function, and then if it's just going to go up higher. No, I'm sorry, it's going to get steeper like this, you know, a little bit more in closer to the y-axis, and that is going to be my k of x for that one. All right, let's look at the bottom part here. So these are now vertical shrinks or compressions because they are smaller than 1. So if I have, and I'm going to write that vertical compression, and I'm going to write that for all of them because all of these numbers out here are smaller than 1. And so I have a parent function that looks like that. And vertical compression is going to make it look flatter. It's going to bring it down towards the x. Okay, so that guy is my k of x. And if I have the basic parent function like that, the same thing's going to happen. It's going to look a little flatter like that. So that is going to be my m of x. Whoops, I should have called that an m of x. And then down here, it's going to be a little flatter. That's going to be my m of x. All right, so just remember, if you see the negative on top, it reflects. These numbers out here, if they are bigger than 1, then they are a vertical stretch. If they're smaller than 1, they are vertical compression. I'm going to back it up so you can freeze that and see it. All right, and that's the notes for today.